for joining our Seed World Strategy webinar, The Science Behind Seed Singulation. My name is Julie Deering. I serve as the editor of Seed World Media, and I'll be your host today. To get things started, I've got a few items that I need to mention. For those of you on Facebook and Twitter, we will be actively posting using the hashtag #StrategyWebinar. We'd like to encourage you to contribute to the conversation online and let us know your thoughts. We want to thank Syngenta for their sponsorship and support of this strategy series, and a big thank you to our speakers for joining us today, Darren Goebel of AGCO Corporation and Sandy Baker of Syngenta Seed Care. We all know that there are many factors that go into achieving the maximum genetic potential of today's hybrids and varieties, and it starts right when farmers open that seed bag or box. Today, we'll examine the role of seed singulation and identify a few tips for success. First, Darren is going to share research from AGCO's 2016-17 crop tour and what they learned from the various trials. Then we will hear from Sandy Baker as he talks us through lubricants and their role in seed singulation. After that, we'll open it up to questions during the Q&A session. So let me go ahead and introduce our first speaker, Darren Goebel. At AGCO, Darren serves as an agronomist and director of global agronomy and farm solutions. In this role, he leads a global team of agronomists who are charged with proving return on investment and effectiveness of advanced precision agriculture solutions and existing AGCO machinery on test farms throughout the world. These efforts lead to product commercialization and support enhanced services to customers. Darren has served as a crop consultant and agronomist his entire career, with work encompassing a wide range of crops and geographies from Southeast Asia to Central and South America. Darren, thanks for taking the time to join us today.
Thanks, Julie. All right, today I'm going to talk to this group about some of the research results that we at AGCO have collected over the 2016-2017 growing seasons. We also have held these same studies in 2018, and we're actually in the middle of receiving and analyzing yield results. In 2016 and 2017, we had active plot locations in the Midwest, as you can see here on this slide. So we covered the Midwest pretty well, and also had a couple locations down in Kansas. Our study design basically looked at four main factors: downforce control, depth of planting, seed spacing, and residue management. In 2017, we added 2 additional studies looking at in-furrow firming and furrow closing. Now, at AGCO, we believe that planting is one of the most critical steps that farmers can do in order to, ensure optimum yields. It's interesting, as a seed agronomist, prior to coming to work at AGCO, I was often called out to look at problems in the field. And now, after this research that we've done over the past 3 years, I can certainly say a lot of it can be attributed to planters, planting practices, and even some tillage in the field. What you're looking at here is a study that we did in 2016 that specifically looked at evenness of emergence. And we were working with Precision Planting at that time to do this study, as that was the first year that we had a collaboration with Precision Planting, putting Precision Planting components on our white planters. Many of you may be aware that we have since purchased Precision Planting and incorporating their technologies on our planters from the factory. But this study, to give you a little bit of background, we actually flagged varieties, or sorry, not varieties, the hybrid as it was emerging in the field, and we looked at 4 different time frames. What we saw on the very first day had emerged. We put a flag on that. Then we came back 24 hours, we flagged that, and so on and so forth. Then you can see here these flags from in the spring. We came and we harvested the ears associated with the individual days that we saw the plant emerge, and then we calculated the yield results. So if we go on to yield results, you can see the 4 different days of emergence that we took, which was the first day, 1 day later, 2 days later, and then up to 7 days later. So we came 1 week later there on that last check. And so what you can see here is that there's a significant loss of yield for late emergers. Just from personal experience, in general, what we find is if we have a plant that's 1 leaf collar behind its neighbors, it will typically only produce about 1/2 of an ear, and that's under fairly good conditions. And if it is 2 leaf collars behind, it'll typically produce no ear, so it's just a weed. So as you look at this data, while we collected plants that came up to 7 days later, likely those plants were coming up actually 3 and 4 days later, and that's just the balance of what we collected. So you can see here that anything after 2 days later, we're averaging about 180 bushels per acre compared to that 225 to 213. So even this emergence is incredibly important, and so this is why we did the research that we did, is to look at the factors that affect that even emergence. Okay, I'm seeing that we don't see a presentation on the list here. Is everybody seeing a presentation? Julie, do we need to wait?
I do see a presentation.
Okay, good.
I see factors affecting consistent emergence.
Okay, super. So then looking at factors that affect consistent emergence, really having even heat and moisture in the seed zone is really, really critically important. And some things that can affect that is residue management. If we have variability of residue covering the seed row, seeding depth, that's going to have an effect based on moisture and to a much lesser extent, maybe temperature very early in the season. Seed to soil content, again, moisture uptake, that's a big critical piece. And then eliminating compaction in the rows. So once we have that plant coming up, if we have too much compaction in the row, we could cause a barrier to emergence. So if we look at the actual data then, this is 2 years worth of data, averaged throughout that time. You can see that as long as we plant at least 1.5 inches deep, all the way through 3 inches, we're kind of maximizing the yield. When we start to get past 3 inches, or when we're less than 1.5 inches, this is where we start to have issues. There's a couple things that go on whenever we plant less than 1.5 inches deep. One, we sometimes don't have uniform moisture in the furrow because of soils drying out close to the surface. And then the other thing that we typically can get is problems with nodal root formation causing what we call floppy corn syndrome. And so good, strong root development is important, and we need to plant at least 1.5 inches to get that. Once we hit that magic 1.5 inches, it's really important that we then plant into uniform moisture. And we want to see that we're in a minimum of 30%, preferably 40% moisture in the furrow. And for the first time, we have the ability to actually measure that with a tool that we call smart firmers. It's also important that we have calibrated row units and that we're actually managing the downforce to maintain uniform depth. You know, the planter row unit will achieve depth as long as we're putting appropriate force down on the gauge wheels to hold it in the soil as it encounters different barriers like compaction, like residue, differences in tillage systems, etc. So that's really important. All right. Okay, so downforce is the next piece then that kind of associates itself with depth control. So what we did here is we looked at what if you have too light of downforce, or what if you have too heavy of downforce compared to automatic delta force from precision planting. Too light is meant to simulate basically a very small spring on a planter, kind of the kinds of springs that we had back in the 1970s, early 80s, before no-till became big and popular. It would be the single springs, the double springs. And then also on a lot of the European planters that are out there, we see a lot of this light downforce as well. Comparing that to excessive downforce, and this would be, for example, a heavy-duty no-till downforce system put in the heaviest setting possible. And so what you're seeing here is a yield loss due to too light of downforce, and also a yield loss due to too excessive. In the upper right-hand picture, you see what we typically can see with too light a downforce, and that is that as planter row unit bounce occurs, as the row unit is sometimes going into the ground to depth and sometimes not going into the ground to depth, we get variable emergence of plants. And this photo was actually taken at our crop tour location in Indiana in 2016, and I saw almost the exact same thing again in Union City, Ohio this year. If you look at the bottom picture, this is what you would see if you have excessive downforce. If you have too much downforce, you'll get roots like on the left, which we would call hatchet roots, that are following the seed furrow, and that's because the gauge wheels are putting so much pressure on the soil surface because of the pressure on the row unit that we literally stunt the roots that are trying to grow where that gauge wheel has ran, to where the roots actually just go down the seed furrow. You can contrast that to the photo on the right, which would have been delta force. We're seeing these same types of things no matter if we're anywhere in the Midwest of the U.S. or in Ukraine or Russia or South Africa, anywhere where we run our protocol, we're seeing these same types of results. Actually, downforce control, in my opinion, is one of the biggest problems on farms today for the planter pass. So you can see a little bit of payback information with an average yield improvement of 9.5 bushels per acre at $3.50 an acre. It's about a $33 opportunity. And delta force system, if you think about the cost of that system, payback's about 723 acres. If you look at the bottom map, it's kind of interesting how quickly it reacts. You can see there's some passes from the previous year in the field and how the system is reacting very quickly and making sure it has enough downforce to actually keep the planter row unit in the ground. Each individual planter row unit acts individually so that as each individual row unit encounters problems or issues, it can maintain that proper depth control without too much pressure. All right, singulation. So we also did a singulation study, and this is one of the first studies that I'm aware of, multi-year, multi-location studies, that specifically looks at singulation and doesn't have an issue with population included. The way that we achieve that is we literally blocked off, I'm going to try to draw these here, we blocked off a couple holes, and then we drilled a couple holes into the plant, or sorry, into the seed disc, so that we could maintain the proper population, but create a skip and a skip and a double and a double. This gave us singulation of poor singulation of 93.1% compared to correct of 99.6%. And then our yield results, we saw about a 7 bushel difference, again leading to a $24 per acre change, and a payback of VSET V-Drive, which solves that problem of 718 acres. You can see the VSET and V-Drive down in the bottom, what that looks like on the planter. Then in 2017, we did this closing study, and basically what we found in the closing study is as long as we weren't in the most aggressive mode, we were averaging fairly, we were maintaining yield fairly well. And I think what happened is as we went into this most aggressive mode, we got some pinch down here between these closing wheels, and basically probably in some cases pushed the seed up in the furrow, and we ended up with non-uniformity in our seeding depth, and then also compaction over the row that prevented the seed from emerging uniformly. And so you can see there is some problems with that. The main takeaway that I guess I would like for you to have on this slide is that you want to make sure that you're closing the furrow well and that you're getting good seed to soil contact, but you should only put enough pressure to do that consistently and not any more pressure than is what's required. So for a no-till system, for example, you may need that closing number 4 setting, but for conventional till systems, which is what we were in most cases in our plots, we probably only needed that closing 1 least aggressive setting. And then from a yield perspective, finally, Keaton Seed Firmer. This was done in 2 locations in Iowa, and what we found in Iowa is very similar results to what we've seen over past studies. A 4 to 5 bushel yield advantage going with this Keaton Seed Firmer, and that's just getting a little bit better firming down around that seed, and with the low cost of those firmers, payback of just 40 acres. Now, different areas of the country like seed firmers better than others, and I think it depends a lot on soil type. If you're in a really, really heavy clay soil with really sticky soils, in those situations, Keaton Seed Firmers may not be the best choice. But in silt loam soils like we saw in Ionia and Morning Sun, there's definitely a really great payback for Keaton Seed Firmer. So that's what I have for you this morning, and I'll look forward to questions when it's time. Sandy.
Great. Thank you so much, Darren. I appreciate you sharing that. And yeah, as we've gone through your presentation here, I definitely have some more questions. Now we're going to hear from Sandy, and he's going to tell us about the role of lubricants in seed singulation. By the way, if you have any questions as we go along, please go ahead and type those in the chat box, and I'll make sure that they are asked during our question and answer session. Okay, back to Sandy. Sandy has been with Syngenta since 2012 when he first started as a project engineer and was responsible for design and implementation of seed treating facilities in Brazil. Today, he serves as North America Seed Care Application Lead and is responsible for supporting key seed care accounts in their seed treating operation with application, quality assessment, training, stewardship, and recipe development services. Sandy, go ahead and take it away.
Thank you, Julie, for the introduction. It's my pleasure to be here with you guys. So this morning, I'm going to approach this slightly different from my colleague here, Darren, today. I'm going to approach it more from the seed treatment perspective. So seed treatments nowadays, those are a very important technology available to farmers and growers. And those are really not optional anymore. Those are really necessary in today's modern agriculture to make sure, people have, good yields and a strong start from the beginning. But as soon as you add seed treatments or any other adjacent technology or adjuvant to your seed, you're changing the characteristics of the surface of your seed. And hence, during the singulation process, you may or you may not have an impact in there. So in reality, your seed treatments should not have any negative impact during planting process. But one of the things we have to highlight is not all formulations are built the same, and not all companies, put the same effort in terms of screening new products and also bringing some of these technologies into the marketplace. So before I jump into some of the topics, there's a couple of best practices and recommendations that I would like to mention, and this is more tackling from the seed treatment perspective. So the first thing we always mention to our customers is, as soon as they get treated seeds, either on a bag or a cubit or whoever type of packaging they're getting, always make sure you keep those treated seeds on a dry area prior to planting. So you don't want to expose those seeds to, weather variation and a certain environment where the seeds would actually pick up some moisture, okay? So that's something quite important because if the seeds get to a tacky phase again, they may end up with more abrasion on the planting disc. So keeping your treated seed on a dry area, it's one of the recommendations that we have, and we always mention that to our customers. The other thing to mention is always use high quality and also tested seed treatments on your seed. And this is really to make sure you have a smooth planting performance and less issue throughout the process of putting the seeds onto the ground. I'm going to highlight later on some of the differences between different formulations and what is the impact they may have on that singulation process. But most importantly on this case, especially when we're talking about singulation, it's always referred to the equipment manufacturer's manual or a certain representative for all the equipment settings. For example, disc size, the disc type, the planting speed, the depth, and all the other parameters that Darren was talking about previously today. So those are very important to make sure the singulation process will be successful and you have a good plant stand on your ground. The other thing, always refer again to the planter equipment manufacturers for the seed lubricant recommendation and use. So seed lubricants are really an important piece of technology that has to be used during this process to make sure there is a proper singulation throughout the planting process. So I'm putting in bold here because I think this is one of the most important things to do is to always use seed lubricants when planting treated seed. And of course, depending on the equipment, depending on the brand, they may recommend talc, graphite, or sometimes a blend of these two products. So always refer to your planter manufacturer, and they should be able to give you a recommendation on what's the appropriate seed lubricant to be used. So at Syngenta, the Seed Care Institute, so we do have an institute in Minnesota. So we have roughly 38,000 square feet of labs for research and development of new formulations. And of course, for every single new formulation that Syngenta Seed Care is putting on the marketplace, we undergo several different quality tests. And as part of some of those tests is, of course, the singulation or plantability is one of the tests that we look at the Seed Care Institute. So just to give you an idea around the formulations, some of the Syngenta Seed Care formulations, they may have more than 15 components inside its composition. So we're talking about, for example, surfactants, some stabilizers, antifoam, some flow aids, and many other components inside there. And the reason our chemists and formulation chemists put some of those components in there is to make sure those formulations are more stable, they have a more uniform film coating, and the ultimate goal as well is to have a better adherence of the seed treatment on the seed. So in other words, we want to avoid, for example, extremely rub-off from those seeds. So, and this is really the point that I want to make the connection here between, a good formulation and a good singulation performance, because the seed treatment is supposed to be on the seed and it should be applied and then it should stay on the seed. It should not be transferred from the seed into the planting disc as a form of rub-off, for example. So the next picture or the next slide I have for you guys may shock you a little bit. So this is essentially one of the issues you may end up having if you don't follow some of the recommendations. So as you can see from that picture, there's a lot of product build up on the planting disc. And as you can see, this is really something that will end up with a lot of singulation issues. So if you see in some of the discs over there, you see some of those seeds kind of stuck in some of those cavities. So of course, every time there's a revolution of your planting disc, you're going to have one seed that has not been put on the ground. So again, this is one of the things you might see there, especially if you're not using a good quality formulation on your seed. And this is really assuming that you have all the correct configurations for your planter, you have added your seed lubricant, And then sometimes if you're not just using a good formulation that has been optimized for this, you may end up with a lot of product deposit on your planting disc. And again, this is mainly because of the adherence of the seed treatment on the seed. If you don't have a good adherence, you may end up with a lot of abrasion, and then hence some of those products will be transferred to the planting disc. And this is definitely something that we don't want to see, okay? The other issue you might have with some of those poor quality formulations is, again, it's the dust off or rubbing off in there. So essentially you're going to have a lot of residue and essentially more exposure to operators. So always ask your pesticide provider to, provide data on the different testings that they do. We do undergo a lot of testings at the Seed Care Institute to make sure our customers will never experience something like what we are seeing here on this picture. So it's all about the customer experience and putting those seeds on the ground without having big issues throughout that process. So again, as I mentioned, we do have a plantability lab here at the Seed Care Institute. And this is, again, part of one of the several tests that we run as part of new product introductions or a certain recipe that we're testing for our customers. And essentially, we are really interested on what is the impact of our seed treatment formulations throughout the planting process. So that's why we have a wide variety of planting equipment. So we do have, wide planters, we do have John Deere's, we do have mechanical versus vacuum planters. And the idea is that independently from which technology our customers are using, we want to make sure they have a good experience throughout the planting process. So that's why we have this plantability lab. And also, one of the things we have very special here is the climatic chambers. So we do understand that the U.S. is a continental country. I mean, from south to north to west and east, the temperature and conditions are completely different by the time farmers are putting the seeds on the ground. So we want to be able to mimic and replicate some of those extreme conditions in terms of temperature and relative humidity, and also test our seed treatment formulations on those conditions to see whether or not we're going to have any singulation issues. So again, we do this for all new products, but also any recipe that we're developing to our customers. And the information that we're extracting out of those tests is really the singulation performance, so the percentage of seeds that we're planting on target, and also number of skips, doubles, and multiples, for example. But the other thing we are looking is more a visual assessment is the amount of product buildup that we might have on the planting disc. So that will be the second thing we are analyzing during those tests. So other than the seed treatment having an influence, and of course the planter settings, right, the vacuum, the speed, and all of the disc size and some other things, the other thing important to highlight here is really the importance of using seed lubricants. So seed lubricants are there to really make sure you have a smooth planting process. They will really, diminish the abrasion between the seeds or the treated seeds and the planter seed disc. And using those according to the recommendation of the planter manufacturers is really, really important. So what I have here for you guys on this slide is just a quick comparison between the same treatment, but then on the left you see that no seed lubricant was applied. And then the two pictures on the right, you see that the lubricant was applied, and on this case here, it was graphite. So as you can see on the left, you start seeing some of those product build up on your disc. And then, of course, this was after 60 minutes of test. And of course, throughout the day, this will get worse and worse. So again, it's very important to understand the importance of those seed lubricants and use it accordingly to the recommendation of your planter manufacturers. So this will really avoid that you get some issues, especially with the treated seeds, that you get some buildup in there, and then eventually you're going to have your singulation affected just because of that excessive buildup on your disc. So this is something that we tell our customers when we do application trainings here at Stanton, and we widely tell that the importance of using the seed lubricants. The other slide that I have here, and I think it's important to highlight this here today, Many of you may have heard about shiny powders, and those are being used widely across soybeans and some other crops as well. And it's important to highlight that those products, those shiny powders, those are based on titanium dioxide or mica on their majority, and those are not really a seed lubricant. So those will not really lubricate your seeds as well as your planter equipment parts. So those are there essentially just for, cosmetic, especially with our seed care, Syngenta seed care products. And in some other cases out there with some other products, they are being used for actually helping dry the seed. So as you can see, the picture on the left doesn't have any shiny powder, and then the two pictures on the right, those have shiny powder. And it may seem that the seeds are actually lubricated, but they're not. And we have run several tests here, and we see, big drops in terms of seed singulation if you don't use the seed lubricants on top of the shiny powders. So this is a certain misunderstanding that we're having on the marketplace, that farmers and growers, they see shiny seeds and they think that they don't need to add any seed lubricant on top of that. And that is, it's really not correct. So always refer to your planter manufacturer for the seed lubricant recommendation, and always make sure you use those lubricants, because shiny powders will not lubricate your seed to the level that you need depending on the equipment that you're using. So this is an important one because it's a lot of people and a lot of growers, sometimes they have some issues, and most of the time the issues are there just because they are not following best practices in terms of using seed lubrication. And my last slide that I have here for you guys today is some of the available resources that we have at Syngenta Seed Care. We do have an online platform that you guys find a lot of useful information about our products and services. And we do have a couple of white papers in there with some recommendations about planting and some of setups for the different planters available out there, and also highlighting the importance of using seed lubricants throughout that process. So that was it from my side. Thank you so much for the opportunity here today, and looking forward for some eventual questions here.
Great, thanks so much, Sandy. I appreciate that. That brings us to our question and answer session for the webinar. And again, if you have any questions for our speakers, both Darren and Sandy, please go ahead and type those into the chat box now. I do have a couple questions here. The first question I have, and this is for both of you, is after choosing the right genetics, it sounds like seed singulation is one of the biggest factors early on in helping growers maximize their yields. What one piece of advice would you give a grower or retailer and agronomist who's working closely with growers?
Sandy, do you want to take that first, or should I?
Go ahead, I'll follow you, Darren.
Okay, good. So I was a consultant agronomist working with growers in the seed industry for about 10 years, and I had a chance to look at a lot of really poor stands, and so it was actually a pleasure whenever I found a producer that wanted to show off his really good stands. So there's a lot of things that can affect it. The planter plays a role, and I think Sandy hit on something really, really important, talking about the importance of talc and graphite. And I would say one of the biggest problems or places where there are problems in the world is Europe, and I would say also Africa, and to a certain extent Brazil. Certainly don't use talc and graphite like they should. From an AGCO perspective, for AGCO planters equipped with precision planting, we recommend the 80-20. And the reason for that is talc on a vacuum planter actually dries out the system. So you think about a vacuum or creating a vacuum, you're basically pulling water into the system. When you pull that water into the system, that mixed with the seed treatment is what causes that really gummy situation that Sandy showed. And the talc dries the system enough that you don't get that. And then graphite just basically acts, somewhat as a lubricant. I guess if you contrast that to like a finger pickup type system, that's where you would use a straight graphite product. You wouldn't want all of the talc in that type of system. So following the planter manufacturer's recommendations is really important. So I second what Sandy says about the importance there of talc and graphite. Beyond that, making sure that you have seed discs that are not worn, and then making sure that if you're not using a V-drive type system, let's say you're using a chain drive type system, or even a cable drive type system, you can have worn parts, worn chains, worn sprockets, low tire pressures. There's lots of things that can cause poor singulation, poor spacing, just in worn parts alone. So you really have to check that planter out and check it out well. And then finally, on a lot of planters out there, if you do have a singulator on the planter itself, you actually have to adjust that to get optimum performance. That's not the case with precision planting. We have an automatic singulator, so you typically don't see those problems. And then finally, I would just say make sure that your monitor shows the kinds of results that you're getting from a planter perspective. And then from there, it's Mother Nature. Do you have too much residue in the row? Did you do a good job with tillage? Did you plant into moisture? And all those things really have a major effect on spacing as far as what actually emerges. So, Sandy, I don't know if I left you anything, but that's your fault for letting me go first, I guess.
That's correct. I mean, pretty similar to what you said, Darren. I mean, one of the things that I would recommend to farmers and growers out there is to be conscious about the decisions they are making in terms of what are the types of seed treatment they are putting on their seed. And again, that's back to the experience, right, that they want to go through. And we've seen some very ugly cases out there that there's a lot of product buildup and issues just because of the quality of that formulation. And then, of course, on top of that, making sure you follow planter recommendations, planter manufacturers' recommendations, in terms of the calibration of your equipment, but also the seed lubricants. Those are very, very important, and they should always be used, and of course, you beautifully highlighted, depending on the equipment, you may go for graphite or talc or sometimes a blend of those two products. So those would be my recommendations.
Yeah, those are both. Go ahead, Darren.
I was just going to say, then there's a couple questions that came in. I think Ricardo and Stanley, I don't know if we should address those now or wait a moment, Julie.
Yeah, go ahead.
So Ricardo asks, is lubricant recommended for any planter, whether they're mechanical or vacuum, and regardless of number of planting lines? Some drying powders are also fluency powders and play both drying and flowability increment roles. How do you see this? I guess I don't really know so much about drying powders other than like talc, and I don't know if maybe Sandy you have that, but yes, either a lubricant or a talc is recommended for all planters. Lubricants typically, lubricant is the graphite, and it does act as a lubricant. It's recommended for mechanical planters, mechanical finger pickups, anything that needs lubricant, versus the talc for more of your vacuum planters. Sandy, do you have any idea on what he's talking about?
Definitely, just to complement that. So there's a couple of products out there that are used to actually help dry the seed treatment on the seed. And some of those products, you actually have talc on its composition. So, but the issue there is when you use those products throughout the treating process, most of those products actually get absorbed by the fume coating of the treated seed. So by the time they are transferred to the planting process, there's not much talc on the surface of the seed to actually help lubricate those seeds. So you gotta watch out for that, because if those products that have talc on their composition are being used in order to help dry the seed treatment on the seed during the treating process, you may not have enough talc on the surface of the seed anymore to actually help the lubrication process, of course, depending on the equipment that you're using.
And it looks like Stanley's question was similar, so I think we got both of those, Julie.
Super, thank you. Darren, one of the questions that I had for you is, when moving from field to field, and you're asking farmers to check their calibrations, you know, how much time do they need to be spending, you know, with the different pieces of their planter and making sure that they're adjusting to certain conditions? Can you walk me through that a little bit?
Yeah, absolutely. So it really depends a lot on what kind of planter they're operating and using. You know, it can be anything from they have a very mechanical planter with spring downforce and not very many sensors on that planter, all the way up to a fully tricked out planter, fully equipped with precision planting components. And I guess if you have the fully tricked out with precision planting, you can probably see 95% of what you need to see in the cab itself. And in that situation, I would probably only, you know, check behind the planter to make sure I have good moisture. And even still, with Smart Firmer now, it'll give you those numbers in the cab itself. Now, if you have a little bit older planter, I would recommend, as you move from field to field and as soil types are changing, especially as tillage practices change, maybe you have a field that you've no-tilled that maybe has some erosion potential compared to something that you've done some tillage in, or even different types of tillage, then setting your downforce is going to be really, really critical. In addition, setting your depth control to make sure that you're in uniform moisture, you're getting a good close in that field. You know, I would even say in some cases you need to check that multiple times in the field, and certainly every time you stop to fill up with seed, be checking those types of things. I'll tell you, the monitor is our best friend in some of those higher tech planters, and you know, relying on that and using that's really critically important. This spring at one of our trial plots, the farmer actually could see in the monitor that he was planting into too dry of soils, but his experience told him that it was okay. And he and I, after walking through some of his fields this summer, he said, from now on, I'm going to pay much closer to what the monitor says, because even though my experience said I'd be okay, when it came right down to it, you know, the monitor was correct. So there's always a really strong element of mixing experience and technology, and you certainly have to do both. But boy, the technology that these planters are bringing today are really helping to simplify things a lot.
Great, thanks for taking the time to answer that. And Sandy, the next
Julie,
question is for you. Yes?
Julie, before you go to the next question, I just want to go back to Stanley's loop question. That might be slightly different from what we answered to the previous one, to Ricardo. So his question was around seed treatment chemicals sometimes come with flowability coatings. Are seed lubricants, talc and graphite, etc., in addition to flowability coatings? And I think what Stanley is actually alluding here is a lot of times we make use of adjacent technologies like polymers, for example. And a lot of times those polymers are added to a certain recipe to make sure we have a better flowability indeed. But that is more on the case of, you know, treating the seed itself and putting the seed through a bagging process, and also dispensing the seed from the cubit or a bag into a planter. But those flowability agents like polymers, those do not lubricate the seed enough during the planting process. So it's very important to acknowledge that seed lubricants are still needed, even though you may have some of those flowability agents inside either the formulation or if you're adding them in a form of a polymer, for example. Thank you.
Thanks for clarifying that, Sandy. I appreciate that. And I think, you know, you may have already answered this in your presentation, but I'm going to go ahead and ask it anyway. from your perspective, what do you think is the worst mistake that can be made in regards to seed singulation and formulations?
In my opinion, the worst mistake is, to select a certain seed treatment product to be put on the seed that has never been tested, for example, in terms of singulation. As I mentioned throughout my presentation, there's a lot of issues, especially if you don't have a formulation that was optimized. You may end up with a lot of issues during the planting process. And again, this is all about the experience that farmers and growers will go through. And we definitely, from the Syngenta seed care perspective, we make everything that is possible in our hands to make sure our products will never perform as badly as some of the pictures we saw during the presentation. So choosing the wrong product and a product that has no data in terms of testing, that's, to me, one of the big mistakes that someone can make. But also following best practices in terms of adding seed lubricant. So seed lubricant is really important. Even if you have a good formulation with a good flowability, with a good dust off and some other parameters, it is still very important to add those seed lubricants during planting to avoid some of those potential issues.
Thanks, Andy. Darren, back to you. In your slides, you had a number of slides and then the breakdown of the different elements from the firmer to planting depth and downforce springs there. And I believe you had calculated the kind of ROI for best practices under each of those. Do you have anything that shows the combination of all three of those and what that looks like in the end?
Okay, yes, that's a really, really good question, Julie, and that's a question that commonly comes up. We started this year actually combining multiple mistakes in the field to see if we could get a cumulative effect similar to the single main effects that we're seeing in downforce, singulation, etc. And so we haven't collected all of that data yet, but in a few locations where we did hand harvesting and hand checks, we saw very similar information. So yes, it is cumulative. It is a cumulative effect, and it would lead to a multiplication of those effects that we saw in the single systems. I think that's your question. Does that answer it?
Yes, it is my question. So I didn't know if you had the numbers there yet or not.
Yeah, I don't. But it's a great question that's come up before, and that's why we started looking at it this year. And so as we'll publish all of our results online at agcocropcare.com this winter, and then we'll also be at Commodity Classic and farm shows, sharing those results.
Okay, super. Well, I think that's it for today. We've had some good questions come in, and I'd again like to thank our speakers, Darren, Goebel, and Sandy Baker, for joining us today and sharing their expertise. We hope that you have found this information of value. And again, thank you to Syngenta for their support of the Seed World Strategy Series. If you want to go back and listen again or want to share this webinar with someone, it will be posted on seedworld.com within 24 hours. That's all for today. Thanks again for joining us. This is Julie Deering with Seed World Media signing off.